So for this example, we want to expand x minus 2y raised to the fifth power. That sounds easy, doesn't it? Often you're going to find in math that the shorter the question you're asked, the more work it's going to take. Where in this case, what we might want to do first is just identify how our pieces fit into that general pattern, that we can think of A as being equal to x in this case. B is something like that minus 2y that we're dealing with here, and n is going to be 5. So, if we want to expand x minus 2y raised to the fifth power, we're going to have a lot of binomial coefficients, so just be patient and bear with me here. We're going to get 5 choose 0 times x raised to the fifth power times negative 2y raised to the 0 plus 5 choose 1 x to the fourth times the negative 2y plus 5 choose 2 x cubed times negative 2y squared plus 5 choose 3 x squared times negative 2y cubed plus 5 choose 4 x times negative 2y raised to the fourth plus 5 choose 5 x to the 0 times negative 2y raised to the fifth, where again we can think of those binomial coefficients as telling us how many ways we can choose those negative 2y terms, those b terms. And then we can take it a couple steps further to actually get a useful representation here. Just bear with me. So we can take those binomial coefficients, write them out as they are defined in terms of factorials. I'm not going to say every single one of them as they're popping up on screen here, so just know that that's the type of thing that they will turn into with a whole bunch of 5 factorials and 4 factorials and 3 factorials and 4 factorials and 0 factorials. And then from there, you can multiply those out, where that 5 choose 0 is equal to 1 times x to the fifth. 5 choose 1 ends up being equal to 5. So we have 5x to the fourth times negative 2y. Then in our third term, that 5 choose 2 is going to end up being a 10. So we'll get 10x cubed times 4y squared, because if you square the negative 2y, the negative 2 becomes positive 4, and we square the y. Then the 5 choose 3 also becomes a 10, where we will have x squared and then negative 8y cubed. Then we have a 5 for 5 choose 4, x, and a 16y to the fourth. And then finally, we have 1 for both 5 choose 5 and x raised to the 0, multiplied by negative 32y raised to the fifth power. And so if we take that horrible, horrible mess, condense it down, find like terms, squeeze out some of those constants, we will get x to the fifth minus 10x to the fourth y plus 40x cubed y squared minus 80x squared y cubed plus 80x y to the fourth minus 32y to the fifth. And looking at this, was that the very cleanest process in the world? No. Was it the very nicest process in the world? And not really. But I still would think that looking at what we had to do here, it's a little cleaner and nicer than if we wanted to FOIL out that x minus 2y thing 5 times. Generally, I'm not a fan of foiling more than once. And we'd have to throw in some new letters because we'd have more than just 2 terms in a couple of those. But this is a more direct way that you can take a general power, where if you want to take this a step further, like if you wanted to square this whole thing and do it all over again, well, we could FOIL, I suppose, if you want to add some more O's and I's in there. Or we could just use the binomial theorem. That's really what the binomial theorem is for, is taking expansions that would be not a whole lot of fun to multiply out longhand and, well, expediting the process. And the very last thing we're going to look at here is how, instead of taking this whole great big pile of things, if we need it, we can just identify single pieces in the binomial theorem thanks to how nice that pattern is, how repetitive that pattern is. We'll see that next.